Hi, this is Professor Stugard, and in this video we're going to talk about exploratory data analysis. So, in this lecture, we're basically going to talk about what are the goals for exploratory data analysis, what's our basic outline for exploratory data analysis, and then what functions we use most of the time when we're doing our exploratory data analysis. So, what is exploratory data analysis, or EDA, or sometimes just data exploration? Basically, the idea is that we're going to use several different techniques to try to understand our data set the best way possible and to make our data set usable. So what we want to typically do when we're doing our EDA is, number one, make sure we understand our variables. Number two, we want to have to clean up our data set. And that's going to be something that happens really frequently when you're dealing with, data sets in the wild. And then the third step is to analyze if there's any relationships in that data. And really the goal is to try to maximize your insights or your understanding of your data set while trying to minimize any potential errors that might show up later on in your process. So we're going to talk about all three of these steps. First, understanding your variable. Now, again, this is where we're really just looking at our data. We want to know what data is included, what our variables stand for, how our variables are stored, and sometimes we want to get a feel for our range of values for a particular variable as well. We might also have to do some more research on what our variables mean, really, and understand what we've included. And then we also want to take a look and see if data are stored incorrectly, because very, very, very frequently they are. Things like dates or percentages or money end up stored as characters, and that's not how we want them stored. And so we're going to have to fix that. Because if it's stored as a character, we cannot do math or any comparison on them. So we'll have to fix that. So our important functions for this first step in understanding is, head. And again, that gives you the first 6 rows of your data set, so you can take a look and see, okay, well, what am I dealing with? How does it look like this data is stored? Glimpse, which tells you exactly how each variable is stored. And then if we have variables that are stored incorrectly, we're going to need to fix those columns, and we're going to use the mutate function, right? That's how we create new columns or overwrite our old columns. And then a parsing function. So again, a lot of times if it's supposed to be a number but it's stored as a character, we use parse number. If it's a date, we use parse date or parse date time. But again, the parsing function is really, really useful. Now, of course, for 3 of these functions, glimpse, mutate, and parse, we need to install tidyverse first. And of course, that's typically going to be the first step in any exploratory data analysis. Step 2, we want to clean up our data. So this is a really important step, and depending on how well we do this can really determine how successful or how frustrating the rest of our project is going to be. There are multiple steps and a bunch of different things we can do, but essentially what we're trying to do is remove variables we don't want and remove rows which have observations we don't need. So to remove our unnecessary variables, well, again, first we make sure we understand what our variables are, what they stand for, and a lot of times we have many just redundant or unnecessary variables that have nothing to do with what we're going to be exploring. And so we need to get rid of them. And so that's a big step, to do first. And then also our variable selection. Again, a lot of times when we encounter data out in the wild, there's going to be lots of missing values, or what are called null values, which in R we see as those values NA. So if I want to examine a variable, but a bunch of those variables, or a bunch of the observations for that variable are missing data or have them as NA, I'm probably not going to want to use that. Missing data is kind of a bad sign. We don't know what we're missing, so we really shouldn't include it. Now, how much missing data is a bad amount of missing data? It's going to be different for every case, and we can set different thresholds for the variables and the data sets that we're looking at, depending on, again, what we're really looking at. A good rule of thumb probably, though, is that if we're missing 40% of the data or more for a particular variable, get rid of it. We really don't want to include it. That's definitely missing way, way too much. So how we're going to do that? Well, first of all, just to remove any variable that we don't want, to remove any column that we do not need, it's the select function. And so select and then minus column gets rid of it. So select is how we remove our columns. If I want to check how much of a particular column is actually missing data, how much of it is NA, we're going to use a combination of functions. So the first function, that one on the inside, is called is.na, and literally that's just going to run through and tell me, okay, is that particular data missing? So we want to use this in conjunction with the sum function. So sum is going to add it up, and so what we plug in as our argument is going to be the column or the variable that we want. And the way we can denote that in R is that we do, as our argument, the name of our data frame, then the $sign, and then the name of our column. And that's basically the format for all of our functions, where we want to plug in just a specific column from our data frame into, well, again, any function that we're using, like is NA. And so again, when we do it like this, is NA, it's just going to run through and it's going to check every data point one by one in that column. So again, we're telling is NA, go to this data frame, and from this data frame, go to this one column, and from this column, we're going to run through, is it NA or not? So the is NA function is returns a Boolean. It returns either true or false. Is it NA, true or false? If it's true, well, that's where the sum function comes in, because R also stores the true and false. True gets stored as 1, and false gets stored as 0, which means if I sum it up, it's going to sum up all the times that it came back true, that it is missing the data, that it is NA. And so again, that'll tell you how many of the observations out of that entire row actually have missing data. And then we can determine whether or not we want to include that column moving forward. Again, otherwise, when we include columns with missing data, well, we're going to get some warning messages. Another part about cleaning your data is, well, removing the rows. So again, we typically have that falling into two categories as well. I want to remove rows that have null values. Like I said, null values are going to cause warnings when I try to do my data analysis, so typically we don't want to include them. Now, that's not always the case. Again, it can be case specific. Sometimes we may want to keep our NA values, but probably most of the time we want to get rid of them. So there's two functions that can do this, the na.omit or the drop_NA. Now, I'm going to say that drop_NA is probably the better one to use as long as you've installed tidyverse first. So you're going to see kind of a pattern that all of our tidyverse functions typically have underscores, whereas the base R has the dots to separate words. So again, drop NA is probably the better one. And again, we can do drop NA using that same argument from before, where we have data, we pipe in our data frame, and then it'll just remove every row that includes any missing data, regardless of variable. Or we can do drop NA and do our data frame, the $sign column, and it'll just remove it for that one particular variable. The other thing we want to look for too is outliers. So again, a lot of these data frames, or a lot of the raw data we come across in the wild, data is entered incorrectly. And again, human error is involved, or sometimes machine error, or sometimes, you know, it just happens, right? There's going to be data that's inputted incorrectly. Or sometimes missing data is entered as a 0 instead of just missing. People are like, oh, I don't know what it is. Maybe it's 0, but that's going to absolutely affect our data analysis in a negative way. So again, a good idea is to just sort your variables that you want to look at in ascending and descending order, get a feel for what the minimums and maximums are. If anything is an outlier, it should be kind of obvious once you arrange your data, what it should be. And then once we know what our threshold should be for minimums and maximums, we can remove our outliers by using the filter function. Right? Filter is how we remove rows, so we can set up some sort of criteria, like saying that we're going to filter any data set or any data point that is, we're going to only keep data sets between two values, right? Get rid of the top and the bottom. Now, once we have that clean, once we've gotten rid of the columns that we don't want, once we've gotten rid of the rows that we don't want, now we can actually start doing our analyzing and see if there are some relationships in our data. Now again, there's lots of different ways that we can do this, but again, typically graphics and looking at graphs and visualizations are the best place to start because, well, we're visual creatures and we can visualize patterns easier than just about any other way to, well, determine if there's patterns. So there's a couple ways we can do that. A good first place is really analyzing our variables with visualizations in our correlation matrix. So we figure out our correlation coefficients for all of our variables and then create a graphic that lets us view those as well. So again, correlation coefficient is that number that's always between -1 and 1. It gives us a bound, and the closer to 1 or -1 we are, the more likely that a linear relationship exists and gives us a good starting point to kind of jump off and do some more well, exploration of our data. Another good one is our scatter plot. Again, that's typically the number one that we're going to use for our bivariate data. And so again, this is we plot two different variables along our two different axes, and again, really useful because we can see very quickly whether there is a relationship between our variables. We can just see it. We can see if there's any outliers that we missed, right? Any extreme data point that's way away from all the other data points, that's going to stick out like a sore thumb in our scatter plot, and we can go back and remove it if we need to. And we can also see that, again, if there's a pattern, well, what kind of function can we use to model that data? So the correlation coefficient matrix and the scatter plots, those are really useful for our bivariate data when we're looking at two variables at one time. If I just want to explore a single variable at a time, histograms are a great place to start. So histograms are basically bar graphs, but they really do show the distribution of a set of values incredibly well. And again, they're going to show any outliers, any extreme data points on one side or the other, and you'll get a real good feel for that one particular variable at a time. Another very useful graph or visualization for univariate data, or one variable at a time, is the box plot. So the box plot might not be as intuitive as a histogram, but it does include a bunch of information in it. It's going to show you the minimum value, the maximum value, again, helpful for determining outliers, and the median values, also Q1 and Q3. And it's a great place to start. Now, those are not the only visualizations you can do. R has so many different visualizations. You can find different ones that you like better and just play around with it. Take a look. So sometimes stacked bar graphs, area plots, violin plots, geospatial visuals, density plots are one of my favorites to use too. Again, you kind of just have to play around with it and see what kind of patterns might exist in that data. And of course, when we're doing this, just because we do those 3 steps in order, that doesn't mean we're necessarily done. Those 3 steps are really just how we kind of choose our models, we choose our attributes, we kind of refine our data. But sometimes we go through all the steps and, well, we got to go back to the beginning. We got to take another look at our data. We might have to remove some other variables or remove some rows and go back and analyze it again. It's not necessarily a linear process where we do 1, 2, 3 and we're done. There's a lot of kind of looping back. And once we have some insight, we go, okay, well, now that I have more insight, what do I need to change? And I can go back and take another look at it. So our conclusion. Well, 2 basic questions. Why do we do our exploratory data analysis? And then how? What are our 3 main steps? Again, another third question might be, what are those important functions and how do we use them? And so, yeah, probably take some notes on those as well. Otherwise, hopefully we have a better idea of our exploratory data analysis, or EDA, and take care of yourselves.